right, so how many times is 5? 5 doesn't go into 4, so you go 42. How many times is 5 go into 42? 8. So where do I put the 8? Above the 2. So then you take 8 times 5 and write it underneath the 42. So 8 times 5 is 40, right? And then what do you do with those numbers? You subtract them, right? So 42 minus 40 is 2, right? Now, 5 does not go into 2, so you bring the next number down, the 5. Now, 5 will go into 25. How many times?
5.
Okay, 5 times. So then repeat the process, right? 5 times 5 is 25. Subtract the two numbers and you get? 0. So then I bring it down the 4. Right? Does 5 go into 4? So what do I put? A 0. What is 0 times 5? 0. What is 4 minus 0?
4.
Okay? Then I bring down the 1. And 5 goes into 41 how many times? 8 times. What's 8 times 5? 40. Subtract and you get 1. Now, when you first learn to divide, what do we call that number? A remainder. Okay, we call that a remainder when you first learn to divide. But then you learn how to write your answers as mixed numbers or decimals. So as a mixed number, you can take the remainder and put it over the divisor. So we could say that this is 8,508 and 1/5. Okay? So that's how you would write it as a mixed number. You take the remainder and you put it over the divisor, 8,508 and 1/5. Does that make sense? Okay. Now the other thing that you learned to do was if you had to write it as a decimal, then you added a decimal point and you brought a 0 down and you said, okay, 5 will go into 10 2 times. So if you did it that way, you wrote your answer as 8,508.2. So you could say 8,508 and 1/5, 0.2, or you could say 8,508 remainder 1. Okay, those are all methods that you should have learned in elementary school. You'll be using this method for polynomials. Okay? That's really the only way to do it with a polynomial. Okay, is everybody okay with that?
Yes.
All right, so our first example. Example 1. We want to take 4x to the 4th minus 12x cubed plus 0x squared plus 4x plus 5. And we want to divide it by 2x squared plus 2. Okay? So we're dividing a polynomial. All right, so to do this, we're going to put it in a long division format. So I'm going to shrink that down so I've got room here. And we're going to write this using long division. Now, one thing to be very, very careful about, you can never skip powers. So I have a 4th power, and you want to check that they go all the way down. 4th power, 3rd, 2nd, 1st, none. So they're in order, right? And no powers are skipped. So I'm good. I just write that in there just like it is. Yes?
If there are power skips,
Then you would put in a, so if there was no 4x here, you'd put a plus 0x. Okay? Because you can always add in 0 times something, right? So inside here, I've got 4x to the 4th minus 12x cubed plus 6x squared plus 4x plus 5. Okay? And then outside, I'm dividing by this, and notice this one does have a power skipped, right? So I have to insert a 0x in between these two when I write it out here. So 2x squared plus 0x plus 2. Okay? Everybody okay with that?
Yeah.
Okay, I'm going to rate, you guys have the original written on your paper. I'm going to erase it so we have more room on here, okay? Move that around. All right, so just like in long division that you had before, now you want to ask yourself, what times this will give me this? And they should always go in evenly in polynomials, okay? Okay, so you need to take this times 2x squared to get this, right?
Yeah.
All right, so I'm going to put the 2x squared right up here. Okay? Anybody remember the next step in regular long division? What did we do with this when we found it? Not yet. We multiplied it times these, what's here, and then we wrote it underneath what was here, right?
Yeah.
So we're going to do that. We're going to take this, and we're going to multiply times all three terms, which means I'll have things to put under these three terms. Okay, so take 2x squared times all three, writing the results underneath these three. So that's going to give me what, 4x to the fourth? And 0 times anything is 0, so that'll be a 0x cubed. And then a 4x squared. Okay? All right, so now I want to, what was the next step? Subtract. So since I'm dealing with negative numbers, I don't really want to have to write subtract, because then it's always, think about in math with integers, if you have 8 minus negative 6, then you have to, I just made those numbers up, but anytime you have a minus negative, you have to change it to a plus, right? You just end up adding the opposite. You end up adding the opposite of whatever you have. So to do that, all we're going to do is just change our signs. We're going to go through and we're going to change all our signs. We're going to change this to a negative. I'll change this one and this one. Change all your signs.
Will they always be nice and positive like that?
No.
Will they be like one?
No, they can be, they might start out as a negative. Okay, so I'm doing a different color. And you're probably, for your notes, I would write out here to the side, change signs, so you don't forget that. Okay? I mean, it should remind you, because when you go to put these together, if you don't change your signs, you're going to get an 8, and your goal is to get a 0. You want this to go away, okay? So to make it go away, you're going to need the opposite sign. So 4 minus 4 is the same thing as 4 plus negative 4. So I just go through and I change my signs. And so now the first term cancels out, which is what I want. When I put these together, what's negative 12 minus 0?
Negative 12.
So I have negative 12x cubed. Right?
Yeah.
And then what's 6 minus 4?
2x squared.
2x squared. Okay, and so the next step would be to bring down the 4x. We bring down the next term just like we used to bring down the last number. Okay? All right, now I start the process all over again. I say to myself, what times this will give me this?
Negative 6x.
6x.
Negative 6x. Is everybody okay with that? You would need to take this times negative 6x to get this. So that's what I put up top, is a negative 6x.
So, what do you?
So what's the next step?
Multiply.
Negative 6x times all three of these, right? So that's going to be a negative 12x cubed. And 0 times anything is 0, so that's going to be a 0x squared. And then I take negative 6x times 2, and that gives me negative 12x. Are you following?
Now do we change the signs?
Now you need to subtract, and subtracting in integers is the same thing as adding the opposite. So yes, we are going to change the signs. So you might write a side note to that. I will do it in a different color. Okay, so change that to plus. Now, what did I have before there? I had a plus, so now it's a minus.
Yeah. Wait.
But it doesn't matter.
It doesn't matter on, yeah, it doesn't matter on a 0. I had a minus.
No, you have
Well,
now.
yeah.
Okay.
You have plus.
Okay, it doesn't really matter with a 0, but I had a negative here, so now this is a plus,
Yeah.
right?
Yes.
Okay, so now when I go to put them together, these are going to cancel, right? And then I'm going to get a 2 here, 2x squared, and then a 4 and a 12, which is going to give me a 16x. And then I have one more number to bring down, the plus 5, and I start the process all over again.
Nice.
So I have to ask myself, what times this will give me a this? A 1. So I have a plus 1, and that 1 needs multiplied times all 3 of these, which I will put underneath these 3.
Wait, what times what? Sorry, I missed that part.
Okay, so what times this will give me this? So that's the question. You start the problem off with what times this will give me this, and then you go, what times this will give me this, and now I'm doing it for the third time. What times this will give me this? And the answer always goes up here. So 1 times these 3, I write down here, and that is 2x squared plus 0x plus 2. Now I need to go through and change all my signs. Okay, so they were all plus, now they're all minus. I subtract, and I get what?
16x plus
These go away, 16x plus 3, and that is my, what? What do we call that?
the remainder
That is our remainder. So what did I do with the remainder?
Put it
over
over 2x.
Over the divisor, right? So I take this remainder and I put it over the divisor, kind of like I did with the mixed numbers. Only you will need a plus sign out here. So we'll put a plus sign and then a 16x plus 3 over the divisor. And you don't need to, for the answer, you don't have to put that 0x in there. You just put 2x squared plus 2. And that is your answer. That whole thing on the top there is your answer. Crazy thing to have to type in, but it is your answer. Everybody okay with that?
Yeah. I have a question. Do they make calculators that like don't solve the problem, but they
Example 2. We have 21 x cubed plus 27 I x squared. I'm going to throw some imaginaries in there now as well. Some complex numbers.
Josh,
7x
thought that was illegal.
plus 9i, and all that is going to be divided by 7x plus 9i. Okay, so we're going to set this up for long division, just like we did the other one. And once again, you want to make sure you don't have any powers missing. So I have a third power, a second power, a first power, and then no x at all. So perfect. Let's just write that in there as is. 21x cubed plus 27ix squared plus 7x plus 9i divided by 7x plus 9i. My x is not wanting to show up there. Okay, so has everybody got the original problem written down so that I can erase it? Okay, I'm erasing this just to give me more space. All right. So how do I start this problem?
You ask yourself what is 21x?
Right, what times 7x will give me 21x cubed?
3x squared.
3x squared, so that's what goes up top, a 3x squared. And now what do I do with the 3x squared?
Multiply it times 7x.
Multiply times both of these and write it underneath these two, right? So then I get a 21x cubed plus a 27ix squared. I didn't plan it, it's a problem directly off of Hawks. Okay? All right, so what should I do now?
You should change your signs.
change my signs. So erase the signs I have. I'll put them in a different color. In your notes, you might want to make a note, hey, change signs out to the side. And these should always cancel out. If they don't, something's wrong, okay? So those cancel. And now what's 27 minus 27? 0, right? So I get 0 here. And so now, what do I bring down? Okay, so what's that?
Could you just bring down?
Yeah, we're just going to bring down the whole thing because, yes, 7x will go in here one time, but then if I put the 1 up here, I'm going to have to take the 1 times this, and I'm going to need a second term for it, right? So it's kind of a weird case. You got this 0 here, so we're going to actually pull down 2 terms at once, okay? Because now I'm going to go directly here and say what times 7x gives me 7x? Everybody agree with that? What times 7x will give me 7x? A 1. So I put the 1 up here. Now I multiply both of these by 1, and I have 7x plus 9i. And then I go to change my signs. And what happens? They cancel, and I've got a remainder of 0 this time. So my answer is just what? 3x squared plus 1 is your answer. So that one has a nice simple answer to it. Everybody okay with that one?
Yep.
All right. All right, so let's do a synthetic division problem. So this is example 3. And it's 4x to the 5th minus 23x to the 4th plus 34 x cubed minus 19x squared minus 19x divided by x minus 4. All right, so crazy long problem. Normally I would do long division with this, and long division will work if you want to do it that way, but I'm going to show you a shortcut called synthetic division. And you can only ever use this shortcut if the number in front of x is a 1 and the power is a 1. So in order to use synthetic division, these two things must be true. You must have a 1 here and a 1 here, okay? So synthetic division requires a coefficient and power of 1. Okay? In the denominator. Only on this x right here. Okay? So you can't do long division unless you have that. Everybody good with that? Everybody got that written down? Okay. So here's how you write, I'm erasing this so that I have room. Here's how you write a synthetic division problem. Okay, you start by you make a little box over here, and you put the opposite of this number. So anytime you put a number in here, you have to think about if you were to set this equal to 0 and solve it. If you had x minus 4 equals 0, and you solved it for x, what would the answer be? 4. So that's always the number that goes inside that thing. So sometimes people get confused because sometimes we have to change the sign and sometimes we don't. Anytime it's written like this, you got to change the sign, but notice there's no equal sign, right? You have to know what x is. What will make your denominator come out to be 0? 4. That's the number that goes in here. Okay? There is no equal sign down here, so you know it's going to be the opposite. All right, now you want to take your coefficients. We only use these numbers here, your coefficients of each term. Once again, super careful. Do I have descending order? 5, 4, 3, 2, 1. Now this one's a little bit different. They're missing the very 0 in the end, right? Okay, so we can put a plus 0 on the end to counteract for that, okay? So when I do synthetic division, I am going to write that list of numbers out. 4, negative 23, 34, negative 19, negative 18, and 0. So that's just all my coefficients, 4, negative 23, 34. And always, it's not a bad idea to double check them. One tiny little error there can mess you up. So now, if you're doing this on notebook paper, you want to save a space for another row of numbers here. We're going to have another row of numbers underneath here, and then I'll have a line underneath that. Okay? Okay, so now, to do synthetic division, the first step is to take this number right here and bring it down below this line. So take that 4 and put it down here. Okay? Next step is to take this number and multiply it times this number. So this times this is what? And that goes here. Okay? What is negative 23 plus 16? How about, yeah, that's right, negative 7. Okay, everybody good with that? Okay, now what? Just keep repeating the procedure. What's 4 times negative 7? Negative 28. Okay, what's 34 minus 28? Okay, and what is 4 times 6? 24 minus 19? 5. What is 4 times 5? Okay. Negative 18 plus 20? 2. And 2 times 4? 0 plus 8. Okay, now this one is your remainder. All right, so what we're going to do now, what was the highest power to begin with? So you notice in the previous problems that we did, we started off with a 4th power here, and we divided by a 2nd power, so we ended up with a 2nd power. We are starting off with a 5th power and dividing by a 1st power. So that's going to end you up with a 4th power down here, right? 5 minus 1 is going to give you 4. So, and synthetic division is always a power of 1 in the denominator. So whatever power you start with, you're going to be 1 power less than that in the answer. Okay, so I'm going to have 4x to the 4th. Just decrease the power by 1. It's negative 7x to the 3rd plus 6x to the 2nd plus 5x plus 2 plus 2 plus 8 over what? X minus 4. And there's your answer. So how do you like the shortcut? Synthetic division is pretty awesome. It is a great shortcut to avoid long division. But remember, it only works if you have a 1 here and a 1 here. Sometimes you have to use long division.
Yeah, we did.
They did here. I can't tell you if you did or not in your Algebra 2. But yeah, if it looks familiar to you, it's probably because you did it in Algebra 2. Okay? Everybody okay with that?
How do people figure out this? Like, did they just sit in the living room trying to do long division?
So now here's another one with imaginary, but it is one I can use synthetic division with because I have a 1 in front of the x and a 1 is my power, right? So yes, I can use synthetic division. So outside my little box, what's going to go in here?
2i.
A positive 2i. Because if I were to set that equal to 0 and solve it, I would have a positive 2i. Everybody agree with that? Okay, now my coefficients. I have a 4 on the x cubed. My coefficient on the x squared is a negative 11i. So you want to be careful with that. Okay? Then I have a 1 on my x, so that's my next coefficient. And then at the end, I have a 3 minus 4i all in parentheses. Okay? So I have 4 separate, this is my x cubed, my x squared, my x, and then no x at all. So here's my 4 terms. All right, so that being said, first step to synthetic division is what?
Drop the 4.
Drop the 4 down. Drop the 4 down, then multiply it times 2i. And 2i times 4 is 8i. Then what do I do?
That's negative 3i.
Add them together. Negative 11 plus 8 is what?
Negative 3i.
Negative 3i. Negative 3i times 2i, be careful with this.
6i squared.
So I'll put that over here as a side note. 2i times negative 3i is negative 6i squared. But remember what I squared is equal to?
Positive.
Negative 1. I squared is negative 1. So I'm replacing the I squared with a negative 1. Is everybody okay with that?
Insane.
Negative 6 times negative 1 is 6. So when I take 2i times negative 3i, I end up with a plain old 6. And to figure out why, it's all over here. This is a side note for getting the 6. So if you need to draw an arrow or whatever to show how we got the 6, whatever works for you in your notes, so you can actually look back, because you're going to look at this and you're going to go, how in the heck did we get a 6 out of that? You'll be, what happened to the i's? What happened to the negative sign? Right? Well, it's all explained over here if you have an arrow drawn explaining it. Does that make sense? Okay, did I give everybody time to get it in your notes? All right, so next step would be to take 6 plus 1, which is 7. Okay, and what's 2i times 7? Okay, now I don't have an I on this, but I do on this. So what I can do is I can put 14i right here, and then just put a 0 underneath the 3. Does that make sense? Okay, so if I were to put those together, I would end up with a 3 plus 10i. Does that make sense?
Yeah.
All right, so my highest power was a x cubed. So now my highest power is a x squared. So I have an x squared, a single x, put a plus sign there because you gotta have something in between them. And then my 7 will have no x's at all. But this is a remainder. So I put the remainder over
X minus 2i.
x minus 2i.
Wait, I have a question. Why
Yep.
is that the remainder? Because we didn't like add it. Like on the last one we added the 0, but we didn't like add that.
So, you mean the last problem?
Yeah.
Okay, so in the last problem, we had we didn't have a complex number over here on the end. We have just a regular number, a 0 plus 8. Okay, so are you asking me why didn't we just add this and then go through that process again?
Yeah.
Because of the I. When I take 2i times 7, I get 14i. And so I can't add the 14i to the 3 because it doesn't have an I on it. Okay, does that make sense?
Yeah. Are we done? With that problem?
Yes. Okay, so is everybody okay with that? So this is the answer that you would type in. Now, another big thing, guys, when you type these in, I mean, double, triple check them. I can't tell you how many times people miss these just because they forget to put a plus sign here, or, you know, they miss a negative sign, or they leave this I out because they're not used to having the I in there, okay? So be super careful with that and pay super close attention when you're typing those in. Everybody okay with that?